Hello everyone, welcome to School of DApps, where we help aspiring developers become skilled blockchain experts across different blockchain network and technologies. If that's what you want, don't forget to smash the subscribe button and hit the notification bell. In today's video, we are going to be exploring BCS, which stands for Binary Canonical Serialization. It is a low-level byte packing format used by the Aptos blockchain. Whether you are just getting into Move or you are building dApps on Aptos already, understanding BCS will give you that deeper insight most devs keep. Alright, let's get started. BCS is just a fancy way of saying, let's take this data and pack it into a bunch of raw bytes so the blockchain can store or move it around easily. Now, the basic idea is packing of data in a raw byte format that would be easy for the blockchain to work with. Think of BCS as the way Aptos blockchain pack data before sending it anywhere, whether it's a transaction or a smart contract call. Now, let's use this analogy to see if it will help us understand better. Imagine you are sending a care package to a friend. You know you can't just throw stuff into the box randomly. I mean your snacks, the clothes, the gadget, and hope your friend is able to unpack it properly on the other end. You have to pack it in a very specific order, maybe even compress it to save space. That's exactly what BCS does. It takes your data like numbers, string, boolean, and pack them into bytes. The analogy might not be exact, but I hope it gives you the basic idea of what BCS is all about. And now that you understand the core idea, let's walk through the different type of data BCS can handle, starting from the simplest, which is boolean. Boolean is the simplest kind of data. It only has two possible values, true or false. Now, when BCS realizes Boolean, it turns true into just one byte, which appears in this format, while false is turned into one byte, which appear in this format also. Because we are dealing with a Boolean type of data, there are no maybes here. If you are trying to put anything other than 0x01 or 0x00, the blockchain will reject it. Alright, let's now look at how BCS handle Boolean. Let's create a variable called var and assign true to it. Next, I will serialize this Boolean value using the BCS library by typing let byte BCS to byte val. This will convert the Boolean into byte. Now, when we print or look at the output, it gives us 0x01 next to integer of size 8. This is just a small number between 0 and 255. It's like saying I'm sending you one object. This kind of number is not a decimal number nor a negative number. It's just a whole number. When you serialize a U8 with BCS, it becomes a single byte. All of them are packed in what we call little endian format. Let's create a variable called var of a type unsigned integer of size 8 and assign 1 to it. Next, we will serialize this value using the BCS library. This will convert the integer into bytes. Now, when we print or look at the output, it will give us 0x01. After U8, then comes U16, unsigned integers of size 16, or unsigned 16-bit integer. This can hold bigger numbers up to 65,000, 535, but it takes 2 bytes instead of 1. Here's where byte order matters. BCS uses little endian format, which just means put the smallest byte first. Let's say you're serializing 1000. In hexadecimal form, that becomes 0x03EF. BCS stores it as 0xe8 0x03. It's like putting your snacks before your shoes into the box. After the unsigned integer of 16 bits, we have the next, which is unsigned integer of 32 bits. This is for even bigger numbers up to 4.2 billion. It takes 4 bytes, still uses the little endian format. Let's create a variable called var of a type unsigned integer of size 32 and assign 1 billion to it. Next, we will serialize the value using the BCS library. This will convert the integer value into bytes. So if you serialize 1 billion, BCS stores it as 0x00, 0xCA, 0x9A, 0x3B. This might look weird, but it is just the raw format the blockchain understands. Next, we have the unsigned integer of 64. We also have the unsigned integer of 128. And lastly, we have the unsigned integer of 256. This all follows the same pattern which we explained in our previous unsigned integer types. Now let's talk about vectors, list or array. A vector is like a list of items. BCS stores two things when it comes to vector. It stores the length of the list using a format called uleb. Then also stores the actual item in the list or in the vector, one after another. Now, let's now look at how BCS handle vector. So we create a vector with 3 unsigned integer of size 8 items. Next, I will serialize the vector using the BCS library. This line will convert the whole vector into bytes. Now, when we print or look at the output, it will give us 4 numbers or 4 items in the array. The first number is 3, is not part of the original list. It's actually the length of the vector, telling us the length of the vector. BCS uses the format called uleb 128 to represent the number of items. Then we get the 3 value themselves, 1, 2, and 3. So BCS is telling us this list has 3 items. Then you get each item serialized as unsigned integer of size 8. Next, we have string data, a special kind of vector. A string is just a vector of UTF-8 encoded bytes. Let's create a variable called name of a type string and assign hello to it. This looks like a simple string, but under the hood is actually a vector of UTF-8 encoded bytes. So when we serialize it like this using the BCS library, the BCS converts the word hello into a raw UTF-8 byte format. Then it treats it just like a vector. First, it stores the length of the string, then the byte for each character. Something to watch out for is UTF-8 isn't always 1 byte per character. For example, let's write a special character. Now, this character we have written looks like 10 characters, right? But when we serialize it, we actually get 24 bytes because characters like this takes more than 1 byte in UTF-8 encoded format. So the key takeaway here is even though it's a string, BCS packed it just like a vector, and every character is treated as raw byte data. Alright, let's get into struct. Imagine we define a struct like this. Struct color. The fields are arrow of U8 of a type U8, G of a type U8, B of a type U8. This is just a custom data type for storing RGB color values, red, green, and blue. Now let's create a value from this. We are saying red has the value of 1, 2, and 3 for the RGB channels. Then let's serialize it using the BCS library. If you notice, we get these outputs 0x01, 0x02, and 0x03. It just outputs the raw byte value in the order in which they appear in the struct. If you notice, there's no feed name, no label, no type info, just raw byte only. That's why both the sender and the receiver must already know what structures to expect, like I told you before. Now, we will look at other data type in the next video. If you have found this video helpful, don't forget to subscribe to the channel, like the video, and I will see you in the next video. Thanks for watching.